Zero. Zero is a necessary part of our lives in the 21st century. It is hard for us to imagine our world without it. But people have not always seen zero in the same way as they have looked at numbers like 1, 2, or 3. In fact, until the 17th century, many religious people saw zero as the work of the devil. This is zero's story from its first use 5,000 years ago in the Sumerian Empire to its importance in computer programming in the modern world. The first time we know that zero was used was 3000 BC in Sumer, an ancient civilization in what is now Iraq. Zero was important for counting in business, and the Sumerians used 2 diagonal lines to show it. They were expert mathematicians in their age. For instance, they could calculate the area of triangles and the volume of cubes. They also made multiplication tables to make arithmetic faster. But they did not see zero as a number. It was more like a sign, similar to the decimal point we use today to show parts of 1. It was never used on its own as a number. Slowly, the 2 diagonal lines changed to a circle. Nearly 3,000 years later, in 331 BC, Alexander the Great, the famous soldier king of Macedonia in northern Greece, conquered the land where the Sumerians had lived and worked. He took zero back to Greece, but it was soon forgotten. It is natural for us to ask why the Greeks did not take this very useful idea into their own mathematics. There are perhaps 2 main answers. First, the Greeks preferred to use lines, not numbers, in their calculations. They calculated by adding 2 lines. As we all know, the Greeks were especially interested in geometry, the mathematics of shapes, not numbers. The second reason was that the Greeks thought philosophy was much more important than something as ordinary as business, and so the use of zero for adding money in the East made them look at it as unintellectual. The Romans followed the Greeks in their intellectual interests, and besides, they did not use position to show the value of numbers. What does that mean? Well, the Romans used the following symbol. 1 equals I, 5 equals V, 10 equals X, 50 equals L, 100 equals C, 500 equals D, and 1000 equals M. They added 3 X's together to make 30. 40 was L with an X before it, meaning that 10 must be subtracted from 50, so XL was 40 and LX was 60. By contrast, the Sumerians, and as we will see, the Indians and Arabs later in history, used the position of numbers to show how much their value was. In this way, 30 shows 3 tens and no units. 33 is 3 tens and 3 units. It's the position of the number 3 that shows us how much it's worth. It also makes arithmetic easier. 33 in Roman numbers is XXXIII. Think about multiplying XXXIII by LXVIII. So the Sumerian 0 got lost for nearly 4,000 years until we find it again in India. The first written record comes from 865 AD, but it was probably used a couple of centuries before then. The Indians also gave us the original forms of the numbers we use today. They thought of 0 as a number too, not just a sign. We know about this from the great Arab mathematician Al-Khwarizmi, who translated Indian maths into Arabic. This allowed advanced mathematics to happen in the Islamic world around the 10th century. Of course, we need to ask why the Indians and Arabs accepted 0, or nothingness, when Europeans did not. This is perhaps because of the different religious beliefs in these countries. In Hinduism and Buddhism, the major religions of Asia, nothingness was a well-known idea. The Holy Quran also says that the world came from nothingness. In Christianity, however, nothingness is problematic because God is eternal and there is an idea that nothing can come from nothing. The English historian and priest William of Malmesbury, 1096 to 1143, for example, said that 0 was dangerous Arab magic and the work of the devil. Even after the great Italian mathematician Fibonacci used 0 in his famous book of 1202, nobody paid any attention. It was not until the late 16th century that 0 began to appear in Europe. It was needed for 3 things: business, pure maths and astronomy, and the study of the stars and planets. Without astronomy, ships' captains did not know where they were at sea or how to reach their destinations. In the late 17th century, the calculus of Leibniz or Newton needed 0. Until that time, mathematics was static. It was interested in looking at what was there, for instance, triangles. Calculus is the mathematics of change. Let's look at an example. A tennis player throws a ball into the air. The ball is obviously moving up and then down, but in the middle there must be a point where it does not move. That point is represented by 0. Newton and Leibniz wanted to look at ever smaller periods of time, and so infinitesimal change or fluxion. But even at this late age, an Irish philosopher and man of religion, George Berkeley, attacked the idea of infinitesimal change and the mathematicians who worked in the area. To him, it was anti-Christian, the same criticism that William of Malmesbury had used 600 years before. Nowadays, of course, we know that all numbers can be written in 0 and 1, or binary, and that computer languages depend on this. In chemistry, there is a theoretical element called tetraneutron, which has 4 neutrons and no protons or charge, and so has a value of 0. In Kelvin's measurement of temperature, 0 is the coldest point, while in Celsius it is not. In physics, 0-point energy is the lowest possible level. 0 is an even number, between two odd numbers, 1 and -1. Without 0, there would be no place between positive or negative, and so on and so on. In other words, 0 is a necessary part of our understanding of science and the world around us. But 0 still causes problems. A silly example. Because there is no year 0 in the Gregorian calendar, the new millennium started on the 1st of January 2000, after only 1,999 years, but should have started on the 1st of January 2001. The problems of 0 are still with us, even today, but we now know that you can make something from nothing.